Hi, in this video, I'm going to show you how to multiply rational expressions. So if you take a look at this first example, we have two rational expressions, which really is a fancy word for fraction. We're going to multiply them together. Now, hopefully you know your multiplication rules for fraction. We're going to multiply numerator times numerator and then denominator times denominator. However, before we do that, because if you see these expressions, before we do that, we're going to simplify these expressions first, and that will make the multiplying part a whole lot easier. The first thing I want you to do after you've written this problem down is I want you to go to each numerator and each denominator and factor the expression that you see there, okay? And I'm going to write that space right down here. So the 2x squared plus 6x, looking for a common factor is always what I want you to start with. It has a common factor of 2x. And then we'll just have x plus 3 left over. X plus 3 is the most factored it can get, so we're good with that numerator. Down here, again, even though there is an x squared, and we usually unfoil problems that have an x squared like that, this is not a difference of squares, and it's not a trinomial, and so we really just need to factor out a common term, which is x, and that leaves us with x plus 2, okay? If you go on to this next fraction, 4x minus 12 has a common factor of 4. So we have 4x minus 3. And then x squared minus 9, it does not have a common term, but it is a difference of squares. And so this is going to factor to x plus 3, x minus 3. All right, here's what we're going to do next. I want you to cancel the matching factor. So if there's a factor in the numerator that you also see in the denominator, I want you to put a line through it to cancel it out. Now, it doesn't matter which numerator it's in. It doesn't matter which denominator, as long as one is on top and one is on bottom. Okay, so the first thing, we can cross out these x plus 3s. There is also the x minus 3 you can cross out. Next, right here, this one you may not catch up on. This is 2 times x and then just an x, so just these x's can cross out. Okay, and there's nothing to cross out. Even though this is a 2 and so is this, the denominator, the one in the denominator, it's connected to the x. So we cannot disconnect them to do that canceling. And then the 2 and the 4, we can't cancel here either because those are both in the numerator. So now we're going to just multiply straight across. 2 times 4 is 8. And then in the denominator, we just have this x plus 2. Now it's up to you. If you want to just drop off the parentheses here, you can. That's what I usually do. And so the answer to this multiplication problem is 8 over x plus 2. All right, guys, let's take a look at this next example. We're still multiplying rational expressions. But again, this one is going to look a little different than the previous problem, but let's work through this one together. The previous problem, the first step we did is we took a moment and we factored each of the different parts. In this problem, because these are just exponents, there is nothing to factor here. So we can really just start simplifying this fraction just from the get-go, just from how it is. Now there's a lot of moving parts here, guys. There's 4 different letters. There's a, b, and x, y, and there's coefficients. So I want you to take this problem really slowly and just do one thing at a time. Let's first focus on the coefficients. And remember, as long as It's in the numerator, and the other one's in the denominator. You can simplify. Okay? 14, 42, 28, and 35 all have a 7 in them, so we can take a 7 out of everything. This leaves a 2 here, a 6 here, and this one leaves a 5, and this leaves a 4. Okay, now we have coefficients 2, 4, 6, 5, but I want you to look at this 2 and the 6. Even though we've already factored out a 7, we can factor out a 2. So I'm going to cross this little 2 out and put a 1, and cross the 6 out and put a 3. Okay, now let's take these variables. Let's just do this in alphabetical order. Okay, I want you to look all the way across the numerator. There is only 2 A's. And then I want you to look all across both denominators. There's also 2 A's in the bottom. So it's an exact match. So both of these A squares get crossed out. Next, take a look at your B's. If you look all across both denominators, I'm sorry, let's do numerator. Across both numerators, there's 3 B's in the numerator, and there's 4 B's in the denominator. So there's 1 extra B in the denominator. So we will cross out 3 B's, but you have to leave a B down in the denominator. Take a look at the variable x. We have x squared in the numerator, x cubed. There's 1 extra x in the denominator. So if we cross out these 2 and cross out 2 of those, we're left with an x. And then notice for the variable y, there's 4 in the numerator and 4 in the denominator, and so both of those cancel. Okay, this is the part where we need to kind of pull what was left over and make our answer. Now, it depends on how nice you write, because sometimes with all of these parts crossed out, it's really hard to see what you have left over. So be really careful, as you put your answer together. Okay, it looks like we just have this 1 times 4 in the numerator. And then for the denominator, we have a 3. I'm going to go ahead and circle it. We have this B, and we have a 5, and we have an x. So 3 times 5 is 15. And then those letters, just put those letters in alphabetical order. And there you have it. There's no other common terms here. So this is your final answer, 4 over 15 bx. Your turn. There's some problems I want you to solve. There'll be some answers to those problems on the next slide.